think this should be working. Yeah. Yep. Good to go. Alright, sorry everyone.
Okay. I'll just get rid of all this. Okay, that's good enough. All right. Okay. I'll just continue then. Okay. So the other thing I was going to talk about is, yeah, so firstly, you can't name variables after special constants that already exist in Maple, so such as pi. And you also shouldn't name variables after function terms. And what I mean by function terms are like if statements, while loops, right? If you do comp sci, you might know if statements. And you can also do if statements in Maple, which is why you actually can't. Look, if I try to name a variable called if over like 5, it's going to be invalid syntax, right? But if I did something like capital I maybe, that's fine, right? Because there is no function term that is capital IF. So yeah, just the whole takeaway of this is name your variables, but don't name them after special constants or after function terms. And one more thing I might have missed is the fact that variable names are case sensitive. So if you name a variable called, if you did a variable called variable with lowercase v equals 1, and then you did variable with uppercase v, and you name that 2, then if you plus them, they should give you 3 because these two are different variables, right? Even though they're spelled the same, they have different cases, so they're case sensitive. That's the takeaway, okay? So pretty simple so far. Okay, so now I want to get to unassigning variables, and you might have seen me do this command before. It's called restart, and essentially it just resets all of the variables you currently have stored. So right now, so remember, I have a variable named if here, right? So if is 5. But if I restarted like this, then if should go back to what it was originally, which is just a meaningless string, right? So restarting means you reset all your variables to their original state. Now, what if you want to reset a specific variable? Okay, so let me just get rid of all of that. Okay, and I'll restart again. So let's say I make a variable named f, and I store 5 in it. So right now, our f should return 5, and we can do f plus 1 should equal 6. Okay, and let's say I want to make a second variable named d, and I store 10 in that. Okay, so d should be 10. And let's say I only want to reset my variable named f. Okay, so I don't want 5 to be stored in f anymore. What I would do now is I would let f equal to quotation marks f, and that, you can see how like it's intuitive, right? If you want to reset f, you just let f equal f, okay? Because f is what it originally was. So now f is going to be f, or d still has the value of 10, okay? So yeah, that's it, right? If you want to unassign all your variables, do restart. And if you just want to unassign one variable, do f. And obviously there's a lot of uses of being familiar with this, because let's say you move from like one question to the next question, then you don't want to use the same variable that you did from last question, right? So that way you don't have to keep on making new variables. You can just restart your current one and still use it, okay? So hopefully that makes sense. Okay. Next thing I want to talk about are constants. So obviously there are a lot of constants, but the 3 main ones you will probably run into in your course are pi, this imaginary unit I, and infinity. And a very important thing here is that if you want to utilize pi, right, you want to make sure that you capitalize the p. Because on Maple, if you type lowercase pi, it'll still return pi, right? But this pi here is actually like a trick pi. There's no number in it. It's just like a symbol of sorts. So you can't actually do maths with the lowercase p pi. And that's why if you want to declare pi, always have uppercase p I, okay? And then you can compute it. So if I wanted to do like 2 times pi, right, I can evaluate. I'll go to what this function means later, but for now, just bear with me. So yeah, that's going to be the irrational form of 2 times pi. But if I try to evaluate 2 times lowercase pi, it's meaningless, right? That's just 2 times the symbol pi, which doesn't make any sense, okay? So I'll reset that. And yeah, same thing with I and infinity. Make sure they're all in the right case. So I is uppercase I. If I did I squared, it should give me -1. And if I did lowercase I squared, doesn't make any sense, right? Maple doesn't know what that means. So key takeaway here is that you have to actually pay attention to the case of each constant when declaring it. Okay, and finally we have infinity, so you can do stuff like 1 over infinity should be 0. Yep. Okay, so stuff like that. And now I will talk about the actual output here. So first we have evaluate F, which stands for evaluate at floating point. And then we have the percentage. So the percentage is a bit easier to explain, so I'll go with that first. Basically, you know how on your normal calculators, right, you have the answer button, the button with the capital A and S. That is basically the most recent answer that you got, right? So this percentage just literally just refers to the last output that Maple generated. So for example, I'll just go with their example here. So if I let A equal the constant pi, and I wanted to evaluate 2 times our constant pi, we get this. And we'll see that our percentage is the same as what we just got. And we can obviously use that we can times the percentage by something. We can do something with the percentage, right? So it's just the same as answer on your calculator. Okay, now the evaluate at floating point function is a bit interesting. I know here it says it displays a number to 10 significant figures, but I want to explain what actually happens here. So the reason it's 10 is because what this function does is there's a constant called digits in Maple, and evaluate at floating point will actually read our variable digits, right? And depending on what digits is set to, it'll display a number of significant figures according to digits. So the reason it's 10 is because when you open Maple, digits is set to 10 by default. So that's why if you try to evaluate, then it'll obviously show 10 significant figures by default, right? But if you want to change how many significant figures you want your answer to be evaluated into, you can just change digits, right? So for example, right now, I'm not going to count it, but there's going to be 10 significant figures here. If I then basically change my digits variable into 50, and then I did this, okay, that's not going to work. Let's say 15. Okay, that's also not going to work. Give me a second. Evaluate at F 2 times A. So again, I'm not going to count it, but this should be a lot of digits, okay? Yeah, this should be a lot of digits, okay? So that's that. Okay, should be the basics done here. So yeah, just a quick summary, right? We have the operations, the brackets. So this is just what you would normally do on your calculator. And this is the important slide here. You want to know how to assign variables. And make sure you use colon equals instead of just normal equals, because that's not going to assign a variable. And also pay attention to the rules with assigning variable names. So they're case sensitive and they can't be named after special constants or function terms. And if you want to unassign all your variables, you restart. If you want to unassign individual variables, you have to just let that individual variable equal itself. And then the 3 key constants, which again are case sensitive, can be declared and used. And yeah, you can also evaluate your result according to what digits you want. Okay, so now we'll move on to Maple functions. And the key thing here is that you want to be able to differentiate between an expression versus a function. So I'll just get rid of this and I'll restart. Okay, so an expression is basically referring to what we've been doing for the past 10 minutes, right? If you ever assign a variable like this, for example, just keep on using that example, this is what we call an expression, okay? And if we, let's reset that, we can also assign exponential function. And you might think, okay, f equals e to the power of x, that's a function, right? But it's not. This is still an expression because Maple doesn't see this as a function that you can input a value x into. So a function is something that you input x into and you generate an output y from, right? But in this case, all we have is an expression, and Maple still sees this as just a variable. It's just saying f equals the exponential function. the exponential equation, okay? So the way you declare a function is you just add one extra step, and I'll show you. So f should be reset right now, yep. So you do the same thing, but right before you write the exponential function, you want to write the input. So we're telling Maple we're about to input a value of x, and we want that to output the exponential function. So now we can do stuff like this, right? Because now Maple is ready to take that input of x and generate the output, that is exp of x, right? So this is how you would declare a function. And I'll just give you an example of how expressions won't work if you do that. So let's say I want my expression to be d equals x squared. See, I can't do this, right? This doesn't work because d itself is x squared, okay? X squared doesn't mean anything right now. But if I did d is equal to x arrow x squared, then if we did d3, it should give us 9, okay? Because we're inputting a value of 3 here, and then we're outputting, according to the function, outputting x squared, which is just 3 squared, which is in turn 9. Okay, the thing is, you can still technically sub in values for expressions, right? But you just can't do, it's not as simple as doing d like bracket 3, for example, okay? So the way you need to sub in values into your expression is by using this command called the subs function. And essentially, you just write subs. The first parameter is going to be your input, right? So let's say I want my input. Okay, firstly, I'll declare an expression. Let's just use this. Okay, so I have an expression called f, and it has x squared minus x, but it's not a function, okay? Keep that in mind. And if I want to sub in a value of 4, I can do subs x equals 4 as my first parameter, and then I want to sub it into whatever my function's variable is called. So in this case, f. And it should give us 12, right? Because 16 squared minus 4 is 12. So hopefully that makes sense. And of course, you can also, this should be covered later, but you can also differentiate your function. And the second parameter x here is just saying, what do you want to differentiate your function, your expression with respect to? So we can differentiate with respect to x, we get 2x minus 1. We can differentiate with respect to y, and we get 0 because there's no y's here. So this is just a constant in terms of y, okay? And that should be it. So yeah, just make sure you know how to declare both expressions and functions. And it's also important to know functions because this should be covered later again, but you can do stuff like plot functions, but you can't plot your expressions. So typically, if the question requires you to do like some substitution or calculus, I would declare it as a function, but otherwise an expression is fine for just differentiating or whatever, okay? Okay, and yeah, you can also declare functions with more than one variable. So it's the exact same format, but in this case, instead of just having x arrow, right, as before, we have, let's say 3 parameters, so x, y, z, and let's say we want our maple to output the Euclidean distance, or square root of x squared plus y squared plus z squared. Okay. So this is our 3 variable function, and it should be pretty intuitive, but the way you would basically evaluate a point with this function, or the way you would pass in inputs, is you do d, and instead of having one variable, instead of having just one number, you put in 3, right? So let's say I wanted to evaluate the distance of a point 1, 2, 3 from the origin. Then I'll just do 1, 1, 2, 3. And yeah, that should, yep, so root 14. And again, just for revision, we can evaluate what we just got to be this, okay? So, yep, that's how you declare a function with more than one variable. Okay. So Maple also has a lot of built-in functions, and what they mean by that is essentially the moment you install Maple, you get access to a bunch of functions, right? And these are some of the key ones. So I'll just go through them. First, we have absolute value. So let's say, I'll just restart everything again. Okay, let's say I declared a function. Okay, so pay attention to the actual x behind the arrow. And I wanted to call this function the absolute value of x minus 2. So right now I have a function that takes an input x and outputs the absolute value of x minus 2. If I try to sub in 0, we should expect a 2, right? Because we sub in 2, we get absolute value of minus 2, and then we get 2 back. Okay, so this is just pretty simple stuff. And we can also do it. Okay, so you've already seen square root, right? From the previous function here, we just did square root. So that's how you declare a square root, unlike on your calculator where you kind of just press a button. But in Maple, you just have to type out square root, SQRT, and then put your square root inside the brackets. Okay. You can also do trig and inverse trig. So in this case, they have trig. Notice how the pi here is capitalized, because remember, if you did lowercase p, it would just be a symbol. So I can actually show you. You'd expect to get, okay, root 3 on 2, right? But if I did pi on 3, see, it doesn't, Maple doesn't know what this pi means. It's just a symbol, a character, right? And I'll just go back to this. And then if I try to take the inverse sign or arc sign of the result we just got, we get pi on 3 back, okay, as we'd expect. Okay, so moving on, these things here are built-in functions, right? But what if you want to use a function that is not built-in? Okay, so for example, you want to plot graphs or you want to solve matrices, right? Those are not built-in functions, and to get access to those, you need to load in external Maple packages. And it's quite easy, honestly. You just have to do use the with command. So let's say you wanted to load in a package called linear algebra. You do with parentheses linear algebra. Okay, so all of these functions here are basically included in this package that you just loaded in. So now you have access to all of these packages. So some important ones are, I guess, linear solve, right? There's also, there should be determinant somewhere as well if you've done that. But yeah, all of the matrices stuff will be included in this package. So you'll probably need to load this package during your exam, whatever, okay? And you can also load in plots. So this should be covered later, but yeah, with this, you can actually plot your functions, okay? And you can plot complex functions too, which is pretty cool. Okay. Okay, so next thing I want to talk about is a special type of function called a piecewise function. And essentially, this is just a function that is split into different functions depending on what domain we have, right? And the way that's structured is, firstly, the function declaration is the same. So here they have an actual expression, but I'm going to declare it as a function, so it's easier to sub in stuff later on. So let's declare that as a function. And first, you want to tell Maple that you're about to declare a piecewise function. Okay, now let's talk about the parameters of the piecewise function. So the way piecewise works is the first input that our function expects is a domain. So we want to specify a domain, okay? So let's specify x is less than 0. And then Maple wants us to tell it what function should we use in case our x falls within this domain. And in this case, we want our function to be 0, right? Okay, and we just do the same for the next input. We just put in the domain of the next domain, and then the function after that. But in this case, we don't actually need to put in the entire domain like this, right? So normally you would think we do this, but the reason we don't need to do that is because Maple is smart enough to tell if a value is not. So basically, let's say you have a value of 0, okay? So in this case, 0 is 0 less than 0. Well, it's not. 0 is equal to 0, right? So Maple knows 0 is not going to fall into this first domain. So then Maple checks the second domain. Does 0 fall into this domain? It does, because in this domain, we can have 0 is less than or equals to x, and 0 is equal to 0. So in this case, Maple will instantly know to go into this domain without actually having the lower bound. So maybe I'll put it down first so you can get a clear example. Okay, so maybe another example I could do. Oh, sorry, I put it the wrong way around. X is less than 1. Okay, let's say I have 0.5, for example. So Maple is going to check the first domain. Is 0.5 less than 0? It's not, okay? So then Maple checks the second domain. Is 0.5 less than 1? it is. So we go into this function here. And another thing I want to talk about is, what if, so we have two domain restrictions here, right? So what if our parameter, our input, falls below both of them? So let's say we want to find the value of x equals -1. So even though -1 satisfies both of these parameters that we have so far, since Maple checks from the left to the right, it's going to automatically validate the first one before going to the second one, because we know -1 is below 0. So that's why Maple is smart enough to skip this check here if we know the first domain is true. Okay, so hopefully that clarifies why you wouldn't need the lower bound for your domains. Okay, and finally, you would expect you can put this, right? But we don't need that, again, for a pretty similar reason. And that's because if Maple knows that our function value doesn't satisfy this, then it must satisfy the third domain. Okay, so therefore, we don't usually, when you declare piecewise functions, you don't actually type out the third domain. You can just skip straight to the function. And this should give you a pretty solid piecewise function. So to test out what we have, right? Let's say I did f of -1. It should give us 0. Yep, because it checks the first domain, it's true. We don't move on to the second one. Let's say we tested f equals 0. It should actually also give us 0. But in this case, it's 0 because of the second function, because 0 squared is still 0. I can do f of half, should give us 1 on 4. Yep, so in this case, Maple checks the first domain. Okay, 1 on 2 is not below 0, so that's false. Moves on to the second domain. 1 on 4 is less than 1, so we square 1 on 4. We return that, okay? And that's about it, honestly. And obviously everything above, we'll do a case where it's above 1, so like 2. We should expect, 3, right? Because now Maple knows that 2 doesn't satisfy the first two domains, so it must be in the third domain otherwise, which is also equivalent to x is greater than 1. So we have 2 times 2 minus 1, which is 4 minus 1, which is 3, okay? So hopefully that makes sense. Okay, and lastly, we just have a few functions that are very useful for simplifying, but not just simplifying. It's more for getting your answer into, and your expression into a form that you want. So I'll just get rid of all of this. Okay, so for example, let's say we want to factorize a quadratic equation, right? We can, by the way, these are built-in functions, so you don't need to download any packages. But yeah, we can just do factor, parentheses, and type in our function. And yeah, factorizes pretty nicely. Obviously notice the asterisk between the 5 and the x, since on paper you wouldn't normally write a times between a 5 and an x, right? But Maple needs a way to tell that there is a times between there, so do that. Okay, we can also do expansions. So normally you'd have to, do your binomial expansion, but if you have Maple, then you can just expand it using the calculator, right? So let's do that. X plus 1 to the power of 3. Yep, so this would just be your three-way binomial expansion. Okay, and then you can also do a cool thing, which is expand your trig identities, right? So we all know this is the sum of two angles, and it should factor into the product of a bunch of cosines. You'll see in a second. Yeah, so this is our, this would be how you would derive your double angle, essentially, okay? So you can do stuff with identities involving trig, and the last two are a bit weird, but essentially, we'll focus on simplify first. So simplify is very useful if after a question you have like a really long solution, for example. And let's say you have a lot of terms, and you're not really bothered to group all the terms, and you have a lot of single terms that you're not bothered to simplify. So simplify is perfect for firstly grouping individual terms. So for example, I have x squared minus x plus 5x squared. Okay, normally you can group this in your head, but for the sake of it, demonstrating, simplify is going to group our like terms, right, which is x squared, and it's also going to group our x as well. And look, let's go through the example we have in the Maple output. So if I did ln x squared plus 2 to the power 5 over 2, notice how here our 2 to the power 5 over 2 is not simplified yet. And obviously, like, this is just an example, right? But in your actual solution, you might have a lot more unsimplified terms. So simplify saves you the time of having to look at each term individually and rewriting it. And in this case, it'll give us plus 16, since 2 to the power 5 is 32. 32 divided by 2 is 16, okay? So there's that. And okay, the next thing is normal. So simplify is your go-to, but if you ever encounter a scenario where you have an expression involving rational functions, specifically functions involving fractions, right? So in this case, you have one fraction minus another fraction, but these fractions are actual functions themselves. So then you can combine the two fractions by doing normal, okay? And there's a lot more you can do with normal. You can look into that in your own time, but one of the most common scenarios of you needing to use this function is when you need to group up rational functions, essentially. So if you look here, it's going to give us a very neat 2 over x minus 1 times x plus 1, okay? So I think that's it. And yeah, I'll just hand it over to Ayusha now.
Okay, hi everyone. My name is Ayusha, and so yeah, let's get started. So firstly, I'm going to go over some basic things about basic calculus. So yeah, let's talk about limits first. So on Maple, you can use the limit function, it's L-I-M-I-T, to evaluate certain limits of expressions. So yeah, let's do an example. So if I want to find the limit of sine x over x, and I want to find the limit as it approaches 0, I would put it in just like that into Maple, and and it'll return me the answer. Likewise, we could do the same thing for a function as it approaches infinity or any specific value that you want. You could also use the limit function to specify whether you want the right-hand limit or the left-hand limit. So for example, let's do limit of the absolute value of x minus 2 divided by x minus 2 as x approaches 2, but we want the limit exactly specifically from the right-hand side. And yeah, that will give us the value 1. And similarly, if we wanted the left-hand side, just do it to double check that they're different answers, yeah, that'll give you minus 1. Okay. So that was everything about limits. You could also use Maple to find your derivatives. So to find the first derivative of an expression, we can use the Maple command diff, which is diff. And yeah, so as Ryle mentioned, it's really useful to first define or assign a variable to a certain expression. So for example, let's do e to the power x times sine x squared, and that's our variable y. And now if we want to differentiate or find the first derivative of y, we would use the diff function, and then first put in the variable that you want to find the derivative of, and comma with respect to whatever you want to differentiate it by. And in this case, it would be by x, right? Yes, and that would give you your derivative. You could also use the function capital D of f to find, or of whatever variable or function, to find the derivative of a function. And what the capital D will do is assign that derivative to a function automatically, the function capital D, which I believe is why it didn't work earlier when Ryle tried to assign capital D to something. So yeah, so let's define the function f first. So as it's then the output, and as Ryle explained earlier, so f is equal to the e to the power x times sine x squared. Yep, and that's our function f. And now if we want to differentiate f, find the first derivative, you would use capital D of f which then assigns this derivative to capital D. And then this is particularly useful when you then want to substitute the derivative evaluate the derivative at a specific value of f. So now we can use capital D of f, and for example, if we wanted to find the derivative at 1, we would add another bracket and do 1, and that'll give you the value of the derivative at the value x is equal to 1. Awesome. So now we can move on to higher derivatives. So for example, if you wanted to find the second, third, fourth, or fifth derivative, we would still use the diff command, but now what we would do is, when putting in your expression, you put in your expression just as normal, and then when saying what you want to differentiate it by, you would add an x, or whatever variable that you're differentiating it by, the amount of times that you want to differentiate it. So for example, if I wanted to find the sixth derivative of sine 5x, I would put in x 6 times into my diff command, and that'll give me the sixth derivative of sine 5x. Of course, when you're finding extremely higher derivatives, it might be a bit tedious and time-consuming to add your variable that amount of times, and a shortcut would be to use the dollar sign. And what the dollar sign does is it kind of acts in Maple. It kind of acts as the word times. So it'll say, I'm going to differentiate sine 5x 6 times. So if I do x $6, oh, missing a bracket here. Very sorry. Yep. If I do x $6, what that's going to do is find the sixth derivative of sine 5x. Similarly, if you wanted to do the same thing for functions, we can still use that capital D of f function, but now you would put in capital D and then the number of times that you want to differentiate it by, so 3 ones would be the third derivative, and then f, which we defined earlier, and that'll give you the third derivative of f. Great. We could also use Maple to do implicit differentiation, so that it's really important, it's really useful when you want to differentiate y with respect to x implicitly, right? And the command we use for that is implicit diff. So for example, if we wanted to find the slope of the tangent on the unit circle x squared plus y squared is equal to 1, again, it's really important to assign your expression to a variable. In this case, let's do simple d. So implicit diff x squared plus y squared is equal to 1, and we are differentiating it with respect to y and x. Oh, I believe this is because we've defined it as something earlier, so let me just use the restart and then try again. Yep, so that returned us the implicit differentiation negative x over y. We can now use this to substitute certain values of x and y. So as Ryan mentioned earlier, you could have defined d as a function and then just did d of x comma y. But since this is an expression, we can also use the subs command. And that just does, and now you can just input your values of x and y. So x would be equal to half, and then y is equal to square root of 3. Oops, sorry. And then y is equal to square root of 3 by 2. And then we're substituting this into our variable d. Yeah, and that would give you negative root 3 by 3. Yeah, similarly, you could do this for equations. So if we have x cubed plus y cubed plus 1 is equal to xy plus 1 the whole cubed, Maple will differentiate the equation for you with respect to x and y. Awesome. We can also use Maple to find the maximum and minimum values of certain functions, and Maple has built-in functions for these operations. So, for example, if you use the maximize function and you just want to find the general biggest possible value, so globally, you just have to use the maximize function, and remember that minimize and maximize here are spelled with a Z and not a S. And just put in your function. So let's do, for example, x times e to the power negative x squared. That will give you your maximum value of that function. But for example, if you wanted to find the maximum or minimum value within a certain range, or within a closed interval, you would then use the dot dot to say, oh, I want you to find the maximum or minimum value within this range. So for example, let's do minimize sine x plus cos x within the range, so x is equal to negative pi dot dot pi. And that's going to give us negative root 2. Great. Yeah. So now we can move on to integration. So Maple can also be used to integrate expressions using the int command. And this is with respect to a certain variable, right? And your integrals can be definite or indefinite. But if you're gonna use it for a definite integral, you have to once again use the dot dot to specify your lower and upper bound. And again, you can assign this integral to a variable or as a function, and just give the expression when you're integrating it. So for example, if we wanted to we assign the expression to a variable f as x squared times sine of x, and then we can integrate f with respect to x using the int command. You also don't have to assign your expression to a variable. You could put in the variable as is into the command. Sorry, you could put in the expression as is into the command. So for example, you can use the integrate command and just put in x squared times sine x with respect to x. Yeah, and then for example, for definite integrals, let's do an example of sine x. So we're integrating sine x with the bounds 0 to pi. Yeah, and that will give you the value for that. Yeah. So now that was everything about basic calculus. We can now move on to the collection of expressions. So let's talk about sequences first. So a sequence is a list of things that are separated by commas. You may have heard of lists and sets which have the brackets around it, right? The square brackets or the curly brackets. Your sequences don't have any brackets around them. And all you do to make a sequence is just type in your variables with commas separating them. So for example, let's define S1 as 3, 3, 3, 3, right? And that's just 3, 4 times. Another way to do this is by, once again, using that $sign to say, oh, I'm going to put in 3 4 times. So $3.4 should actually just return us the same sequence. You can also use, there's a built-in function called sequence, which is SEQ. And if you specify what variable you want in your sequence, in this case, constant would be 3, and then specify how many times you want 3 to be in there. So if we, for example, if you see in the output they did 3.6, this is basically the same thing as saying, oh, I'm going to have it between 3 and 6 times. So that's going to be 3, 4, 5, 6, which is 4 times. So actually, it's just going to return us the exact same sequence that we had earlier. That might be a bit confusing to understand what that k value actually does, but what it does is it makes most sense when you have like a variable, for example. So if I had 3 times of k plus 1, it would then substitute my k value into this sequence. So for example, that would be the sequence we get in return. Great, so now we can talk about sets and lists. So to enter a list into Maple, you would use the square brackets, as I said earlier, and to enter a set, you would use the curly brackets around a sequence, right? So, for example, if we wanted to define the set, so S1, capital S1, as the set of the sequence S1, which we had defined earlier, so this is simple S1, you would get the set containing 10, 13, 16, and 19. Also remember, earlier I had defined all 3 of these sequences as S1, so what Maple does is it takes whatever the latest definition was, right? And basically every time you assign the variable again, it's just replacing whatever your old whatever that variable was assigned as before. Yeah, so that's your set, capital S1. And then what you can do with this is you can retrieve a certain value in your set. So for example, if I wanted to retrieve the second value in my set, I would use the square brackets around 2. So if I do capital S1 and then put the square brackets around 2, it would retrieve me the second value from that set. Similarly, you can do the same thing for lists. So I can define the list L1 as the list of the sequence S1, which I defined earlier, right? So so that converts our sequence S1 into a list. And then similarly, you can use the square brackets to retrieve even a certain number of elements in your list. So for example, can't use 3 to 7 here because there's only 4 items in our list, but we can do, let's say, 1 to 2, and that'll retrieve your first and your second item in your list, right? You could also use the square brackets to assign a certain item in your list to a constant or expression, right? So for example, if I have 10, 13, 16, 19, I can assign my third item in the list to, let's say, 20. And then it'll replace that third item with 20. Great. So now you can also use Maple to turn a sequence into a set or list. So as we said earlier, we turned a sequence into a set or a list by putting it inside the square brackets or the curly brackets, right? But if we wanted to convert, for example, a set into a list, we would use the convert functions. For example, let's just define some sequences. So sequence would be 1 and 2, and then our set would be the set of SQ, capital SQ. Yeah, and now, for example, if I wanted to convert my set ST into a list, which this, I believe, should actually be simple L, IST, because that's how Maple interprets list. Yeah, and then it converts our set ST into a list, which we can, for simplicity, define it as L. Awesome. And now, if you wanted to convert, for example, a set or a list back into a sequence, you can use the op command, so that's OP, and then put in whatever your set or list was. For example, I'll use L, and it'll convert it back into your sequence. What it does just removes the brackets from it. Just remember, like here, I keep assigning certain expressions or lists or sequences to variables, but if you wanted, you could put in the list or the set just as is into the functions. For example, if I do 1, 2, 3, 4, the list of 1, 2, 3, 4, it'll convert it to the sequence 1, 2, 3, 4. Awesome. So now we're going to move on to sums and products. So Maple can add and multiply the terms in a sequence, set, or a list using the add and mul commands. And as you would guess, the add command adds things, the mul command multiplies things. So let's do some examples of that. So for example, if I define L1 as 3, 7, 18, right? The list containing 3, 7, and 18. And then I want to add some variable k plus 2, where my k is actually equal to L1, which is the list that I defined earlier, right? Yeah, so it just adds up all the terms in the list plus 2 for each term. And similarly, if you wanted to multiply k, where k is now equal to a sequence from 1 to 10, it would basically just give me 10 factorial, right? Awesome. Now, you might be wondering about the sum and product commands. So they act kind of in the same way, where it'll add or multiply all your terms in a list, sequence, or set. But now, when you have an infinite number of terms, that's when you would use sum and product. So for example, if I wanted to do, if I use the multiply, the mul function to find this, the product of all integers from 1 to infinity, right? Obviously this has no end. It's going to give us an error because the multiply function doesn't actually work for that use. But if we substitute this with product, it'll give you the answer infinity, which is obviously the right, yeah. Similarly, if I used add here, so I was just adding 1 to infinity, it's not going to work. But if I use sum, it will work, and it'll give us the value infinity. Great. Now we can go to manipulating structures. So there's a bunch of commands that you have that'll basically return you a certain value depending on what the command is. So for example, the nops command will return you the number of terms in a list. So let's, for example, define a list. L1 is the list containing 3, 7, and 18 times of y, some variable y. If I use nops, if I use the nops command, and I'm using percentage here, which, as Riley explained, percentage is, it's like the answer button in a calculator, and it just uses whatever your last returned value was. And so the number of terms in L1 is going to be 3, right? Similarly, you can use the subs command, which substitutes a value into your list, sequence, set, whatever it is. So for example, y is equal to pi. So obviously I had my y variable in L1, but if I substitute y is equal to pi into L1, it'll now give me 3, 7, and 18 pi. The map function applies a function to all your variables in a collection. So for example, if I did map cos of L1, it just applies the cos function to all the variables in my list. So basically to the 3 terms in my list. Similarly, you can use the sort function to arrange the terms in a list in increasing order. So for example, I'm going to define a new list as, let's say, 2, 3, 1, 4. And I want to sort this in ascending order. You would sort L2. Ooh. Sorry, miss the equals to sign here. If you sort L2, that'll give you L2, but in ascending order. 1, 2, 3, 4. Great. So now we're going to move on to complex numbers and equations. So obviously we all know what complex numbers are, and the most basic complex number is I. And as Ryle mentioned earlier, Maple understands I, so the square root of -1, as capital I. Yeah. Don't confuse it with simple I, because that's not going to work in Maple. It's just a meaningless variable, but capital I you can then use in your calculations. On complex numbers, you can apply any normal operations such as addition, subtraction, multiplication, powers, roots, whatever you want. But for certain operations such as square root and exponentiation, Maple returns these values to you unevaluated, and to get your exact answers, you would then need to use evalf or evalc, which I'll demonstrate, to get your exact Cartesian form or your numerical approximation. So, for example, if I define z1 as 23 plus I upon negative I plus 45, right? Well, obviously that gave us our Cartesian form already, but you would use the evalc function on z1 to return it in Cartesian form, right? And then evalf would give you the same answer, but to the number of significant figures defined in your digits function. Yeah. In this case, it would be to 10 significant figures. Awesome. So now if we go to complex number operations, so obviously we know that there are certain operations we can apply on complex numbers. Firstly, you know that there's the real and imaginary parts, and Maple has functions for these. So you can retrieve, for example, we had Z1 earlier, so I'm just going to use the same thing. So RE of Z1 would be the real part of Z1, which Maple retrieves as this value. And then likewise, the imaginary part of Z1, Maple would retrieve as 45/2026. Great. You could also use the functions argument, abs, and conjugate to find the angle, magnitude, and the conjugate of a certain complex number. So for example, the argument of Z1 is arctan 45/46,597. And just keep in mind that this argument function will return your value in terms of arctan y/x, right? And then similarly, your absolute value or your magnitude of Z1 would have been this, and your conjugate of Z1 is this. Just to keep in mind, you can assign any of these expressions into variables, which will then let you apply certain operations on them later instead of having to type this out every single time. Great, so that was everything about complex numbers, but now we can move on to equations. So something to note is mostly we have been dealing with expressions and not with equations. And a good thing to remember is when you're dealing with equations, you know, normally like if we said x is equal to 5 and 5 is equal to x, for us that kind of means the same thing, but to Maple it doesn't. Because, so let's say for example, I'll use an example of 2 times of x plus y is equal to 5, right? That returns us our equation. And you can apply certain operations on equations like addition, subtraction, multiplication, or division. So let's do that. For example, let's do equation 1 plus, you can add another equation to it. So let's do 23 is equal to x, and then divide the whole equation by 3. That would return us this value, right? But for example, if the equation that we added was not 23 is equal to x, but x is equal to 23, it would return the value, but it's then added the x and the 23 to different sides of the equation, which is not going to mean the same thing as 23 is equal to x. Yeah, similarly, you can use Maple to define new equations using old equations. So we can say equation 2 is going to be equal to equation 1, so EQN1, divided by 32 is equal to x, divided again by 64 is equal to y. And that'll give you this final equation. You can also use the commands RHS or LHS to retrieve a certain part of your equation. So RHS is going to retrieve your right-hand side of the equations. For example, if I wanted the right-hand side of equation 1, you get 5, and then similarly, if you wanted the left-hand side of equation 1, you'd get 2x plus y. So now when we're dealing with exact solutions, there's a number of different ways that you might be able to get your answers. So for the most part, we use the solve command to solve most algebraic equations. And when you have an equation with multiple variables, you would then use the second argument to say, oh, I want to solve for this specific variable. It's also important to remember then, like for polynomials, when you have a degree greater than 2, when you get multiple solutions, and then let's say you're gonna do some operations on these solutions further on, it's going to be useful to define those solutions as a list to then compute operations on it. Because when you have it as a sequence, which is how Maple returns it, you're not exactly going to be able to do any operations on those values. So let's, for example, ask Maple to solve 3x plus 4 is equal to 5x. It'll return us this value, right? So that's just a really basic example. But if we use the solve function on, for example, ax squared plus bx plus c is equal to 0, and we want the answer specifically for x, it'll return us these two different answers, right? But because we have two different answers, it's going to be particularly useful to define it as a list. So let's do the list of, and use the percentage, because that's our last retrieved answer, right? And then this is useful if you want to pick out a specific answer that you got. So for example, it'll be more useful when you're dealing with higher powers, for example, like 3, 4, or 5, and you want to retrieve a certain value that you got. So we can say, I want the second value that in this list, and it'll give us the negative answer. Great. Yeah, so now when you're trying to solve simultaneous equations, you can still use the solve function, but now because you're going to have two equations that you want to solve, you want to put those two equations into a list, and also because you're going to have multiple variables, you want to put those variables into a list as, not a list, I misspoke, sorry, a set. You want to put it into a set as well. So let's, for example, define two equations. Equation 1 is going to be 2 times of x plus y is equal to 5. And then equation 2 is going to be x minus y is equal to 4. You could define your variables if you want, sure. The set of your variables. So the set of your variables is going to be x comma y, right? So now if you want to solve these two simultaneous equations, you'd use the solve function on the set of equation 1 and equation 2. And you're going to solve it with respect to x and y, which we defined earlier as the set of variables. And that's going to get your answers x is equal to 3 and y is equal to 1. You can then use the function assign to assign whatever your values were, right? So if I use the percentage symbol, what that's going to do is it's going to assign the variable x to 3 and then assign the variable y to -1, as so. And then it's particularly useful when you want to apply operations onto it. So for example, if I wanted to do x plus 10, it would take that value 3 and then add 10 to it, which is 13. Yeah. And yeah, once again, I'm just going to use the restart function to get rid of that assigning. Yeah. Yeah, so when you're solving simultaneous equations, or equations in general, if no solution exists to the equation that you've given, you might expect Maple to return like an error or something, but what it actually does, it just returns a blank line. And then if your equation has an infinite number of solutions, what it'll do is it'll return an expression or multiple expressions that are written in terms of a fixed variable. So for example, if I wanted to do solve 2x plus y plus z is equal to 5 with respect to x, y, and z, right? So I want to get the answers for x, y, and z. You might know already, but this equation has infinite number of solutions, and Maple just returns those solutions with respect to like fixed values, and then an expression for whatever the other variable was. Yeah, another thing you can use Maple for is to find approximate solutions of certain equations. So the fsolve function will return your solutions to a certain number of significant figures. In this case, it will be 10. Yeah. So if we wanted to find the solutions for x squared minus 2x plus 2 is equal to 0, and then we want the solutions for x, yeah, what you might notice here is that fsolve sometimes needs our help with certain things. So for example, if I have just put in the equation as so, it doesn't return me a solution, right? It just returns me an empty a new line because it thinks that my equation has no solutions. But I know that it has certain complex solutions, And what you're going to have to do in this case is just tell Maple that your solutions are going to be complex, right? And so what you want to do is just add another comma and say complex. And now it'll return me my complex solutions to the equation. Yeah. Similarly, if you wanted the solutions for an equation within a certain range, you can define that range by using the two dots as we did earlier. So if I wanted to find the solutions to the equation x cubed minus 3x squared plus 2x is equal to 0. Again, I want the solutions for x, and this time I want it within the range -1 dot dot 3 by 2. So it's going to give me the solutions within that interval. And yeah, and I have my two solutions. Yeah, and I think that was about it. So yeah, so now I'm going to pass it on to Sarah.
Alright, so now we will move on to plotting. Alright. So I'll just restart everything real quick. Okay, so now at plotting, so what we use is the plot function whenever we want to plot a graph. So let's say I wanted to plot the parabola function. So what I would type up is plot bracket x squared, comma, and then what I want to do is I want to write down the range of x values for which I want it to plot over. So let's say I wanted it to go over -1 to 3. So I put -1 dot dot 3, and then I close the brackets off. And then when I hit enter, what it should do is it should generate this graph over here where the x values lie from -1 to 3 as shown on the screen. What I can also do is I can plot the tan function, for example. So I have tan of x, and I want my x values to lie between 0 to 2 pi. Keeping in mind for 2 pi, I type this up as 2 times pi with a capital P. But the thing is, I also need to have a set of like y coordinates to compress it or like fit it within a certain range. Otherwise, it'll just go off to infinity or negative infinity. So to set my y values, I type -10 dot dot 10 and close off the brackets. So now when I hit enter, the graph that's been generated, in terms of the x values, it ranges from 0 to 2 pi. And in terms of the y values, it should range from -10 to 10, as follows. So now, let's suppose I wanted to graph 2 or more graphs within the same set of, or the same plane. So what I would have to do is I would have to initially type up my functions within a list. So how I would do this is I can just name it graphs, and in my list, so let's say I have x cubed plus x plus 1, comma, and then I write my second function that I want to plot, so 13x minus 15, and then I close this off with the square brackets. So now when I go ahead to plot this, I type my plot function, then I type graphs, comma, and then I want to specify the required domain that I want the graphs to be plotted over. And then when I hit enter, it should generate this over here. So the two graphs have now been are now seen on the plane as follows. So moving on now, so sometimes your equations may not be in terms of x and y, they may be in terms of a third variable, for example your parametric plots, which are in terms of t. We can still go ahead and graph this. So I use my plot function, and then inside my curvy brackets, I put my square brackets, and then I type my parametric equation. So I have cos t, comma sine t. And then with a comma, I write my parameters for t. So that's 0 dot dot to 2 pi. And then I close it off with both brackets. And then what this should generate is my circle equation on my graph. Also keeping in mind, let's say I previously set the t variable to an integer. So let's just say I set it to 16. Now when I go ahead to plot the function, if I press enter, I'll get an error because it's reading t as an integer value, not as a variable. So what I need to do is I need to either restart by typing restart and hitting enter, or what I can do is if I don't want to erase all of the memory, I can just do t equals to, and then with the apostrophes, just type the t out. So what this will do is this will just remove the assigned value to t. So now when I go ahead and plot my graph, that should work because t is no longer assigned to an integer value. So moving on now, sometimes you may be asked to plot polar plots or implicit plots. So for this, the with plots library or package isn't required. So what you want to do is you want to go ahead and first download that. But yeah, so now once that's happened, to graph up our polar plot, we use the polar plot function, and then within the brackets, we type the equations that we want to graph. So let's say I have 1 minus cos theta, where theta ranges from 0 to 2 pi. So theta equals to 0 dot dot 2 asterisk with the pi. When I click enter, I'll get my polar plot as shown on the screen over here. Likewise, if I wanted to plot a implicit plot, so what this means is that my equations won't necessarily be in terms of y. So this equation, x times y equals to 1, is my hyperbola graph. So let's say I wanted to graph that out. So x times y is equal to 1, where my x values range from -2 to 2, and my y values range from -2 to 2 as well. What this will do is this will graph up my hyperbola, implicit plot. Yeah, so this will graph up my hyperbola within the required range and domain as shown. So previously we were graphing lines and curves. What we can also do is we can also graph data points on Maple. So let's say I have a set of points. So I'll just quickly restart. So let's say I have points. What I want to do is I want to write them within a set list. So in my list, let's say I just had these coordinates over here. So I'm just going to plot these 3 points onto a graph, but you'll notice that, so I have my set list, but you'll notice that it may not necessarily work if I just straight away type it up like this inside my plot function. Because now what's happened is that it's just generated a straight line between all the points. So what I need to make sure is I need to make sure that within my plot function, after I type up points or like the name of my set list, I also need to set the style to point. Otherwise, it will just join up a line between all the data points. So now when I click enter, you can see that there's 3 points on my graph as shown. What you can also do is you can also use the sequence function to help draw up graphs using points. So let's say, I'm going to restart. Let's say I had my points list where I have in my square brackets a sequence ranging from 0.1i to sine 0.1 times I, where I've set I to be between 1 and 100, so equals to 1 dot dot 100, and then I need to close it off with the required brackets. So yeah, so all of this over here, these are just my coordinates which lie on my graph over here. So we'll have 100 sets of coordinates. So now when I go ahead to plot this, So I want to plot my points, but I need to make sure that my style is set to point. And now when I hit enter, I should get my sine curve where all the data points are set to the point style over the domain of 0 to, over the required domain for the given I values from 1 to 100. So now moving on, so that concludes the plotting section of the workshop. So now we'll head on to linear algebra. So whenever we're creating vectors in Maple, what we want to do is we can write our vectors either in terms of a column vector or a row vector. So let's say I have U, which is my column vector. To write a column vector, I start off with the less than sign, and then I type my elements up by separating them with commas, and then I close it off with the greater than sign. So what this should do is this should generate my column vector, which is vertical. To write up my row vector, what I would have to do is, the notation is quite similar, however, instead of commas, I'm using the vertical bar. So I'm separating out all my elements with the vertical bar, and I still open and close it off with the less than and greater than signs. And then when I click enter, this will give me my row vector as follows. So yeah, there's two different sets of notation we can use to write up our vectors. So what that means is that our matrices can be written, like the same matrix can be written in two different ways. So for example, let's say I had my matrix M. My first one is 3 sets of column vectors. So as you can see, 1, 4, and 7, that will make up my first column vector of my matrix. And then I separate the first column with the vertical bar. The second column is written as 2, 5, 8, and then I close it off, followed by an absolute value or vertical bar. And then I follow it up with 3, 6, 9, separated by commas. So as you can see, each of these 3 sets represent 3 different column vectors, which I inserted into my matrix over here. If I can also interpret this as 3 sets of row vectors. So how I would do that is, let's say I had matrix N. The notation is a bit similar, however the commas and the vertical bar swap. So I start off with 1 vertical bar, 2 vertical bar, 3, and I close it off and follow it off by a comma sign. So the 1, 2, 3 is the first row of my matrix. Then I want to type up my second row, which is 4, 5, 6, keeping in mind that all the elements are separated by the vertical bar. And then I finish this off with a 7, 8, and 9. And I close it off with my greater than signs. And then when I click enter, what you'll notice is that matrix M and matrix N are completely identical to each other. So you can type up your matrices in either way. Both will end up giving you the same output, but just keeping in mind that the order of your elements really does matter. So although both of these gave the same output, over here we were typing up the column vectors one by one, but in the second example we were typing up the row vectors one by one. So now moving on. So with a lot of the linear algebra stuff, it's very important to download the required package. So I'll just restart and download the package using the with function. So with linear algebra as follows. So whenever you have a matrix, you can extract a specific value from the rows or columns. So let's say I have my matrix M, which is which in the first column is 1 and 2, and then in my second column it's 3 and 4. So this is my matrix M over here. If I want to just extract out the first row, what I would do is I use the row function, and then in my brackets I first type my matrix M, and then I type 1. And then when I hit enter, what you'll see is that the first row of my matrix was extracted out of it. Likewise,
Have it open on your browser, the live stream. The making live stream.
So that's this one.
Yeah, so open it, and it should connect. Oh, duplicate stream. Oh, I hope we didn't fuck this shit up.
Because that's what I've copied there.
Do we cook this shit up? Who's that?
That's all. I think that's just the old one, essentially. That's the one from last year.
I
So
hope,
we
bro.
we just copied that, right?
Black? I think we cooked this shit up. It's live. Wait, no, okay, this is us.
No,
it's
yeah,
fine.
no, that's good. That's good. That's good.
Why is there nothing showing up for Math 1A?
That's weird.
Are they done? 1 concurrent viewer? 5 likes, so that's pretty good. Okay, maybe we didn't cook this shit up. But I'm not sure. Select a new key below.
I mean, it's